So this question says construct an equation for a function with vertical asymptotes at x equals -5 and x equals 3/7 and a horizontal asymptote at y equals 6. So several possible answers for this. Let's go ahead and recognize what we're looking for. Again, x equals -5, x equals 3/7. Horizontal asymptote at y equals 6. So vertical asymptotes will happen where these elements are not defined in the domain. So if x equals -5, that means x plus 5 would be 0. So that would make the denominator 0. So in terms of my f of x, I'm going to start by putting an x plus 5 in the denominator. I also have x equals 3/7. So that'd be the same thing as saying x minus 3/7 is 0. Okay. The problem with that is we don't have a simple way to do that. I could write x minus 3/7 downstairs, but that's not simplified. So maybe better than that, let's multiply both sides by 7. So currently we have x equals 3/7. Multiplying both sides by 7, I get 7x equals 7 times 3/7. So we get 7x equals 3. Now subtract 3 from both sides, and we get 7x minus 3 equals 0. So if that's the case, we're going to have a 7x minus 3 in the denominator. So you'll notice if we multiply that stuff out, what do I have? X plus 5 times 7x minus 3. (7x) times x is 7x squared. -3 times x is -3x. 7x times 5 is 35x. 5 times -3 is -15. So putting all that together, what do we get? We get 7x squared. 35 minus 3 plus 32x minus 15. So I have f of x. The downstairs part that I have is 7x squared plus 32x minus 15. And we hope that if we do that, we will have a vertical asymptote at -5 and at 3/7. So let's just put something simple up there. This does not have the correct horizontal asymptote. Notice currently the degree of the bottom is 2, the degree of the top is 0. The bottom grows much faster. The horizontal asymptote for this function is not y equals 6, it's y equals 0. But I want to check to make sure that my two vertical asymptotes are correct. So let's go to Desmos and see what that function looks like. So currently, if I have this function, f of x equals 1 divided by 7x squared plus 32x minus 15, we hope we see vertical asymptotes at x equals -5. Do we see that? It looks that way. So x equals -5 certainly appears to be a vertical asymptote. And then the other one is supposed to be at x equals 3/7. Let's see if that's the case. X equals 3/7. And yeah, that looks pretty good. So now we have to go ahead and adjust the horizontal asymptote. Now, how are we going to construct a rational function that would have that as a horizontal asymptote? Well, I need the degree of the top and the bottom to be the same. So the degree of the bottom is x squared. I need the degree of the top to be x squared. So if I just put x squared up top and nothing else, the degree of the top is x squared. And then put 7x squared plus 32x minus 15. Although now, what would my horizontal asymptote be? it would be 1x squared over 7x squared. My horizontal asymptote here would be 1/7. I want the horizontal asymptote to be y equals 6. So what do I need the top to be? I need something divided by 7 to equal 6. That would be 42. So here's where we are currently. We are at f of x equals something x squared over 7x squared plus 32x minus 15. And I want the horizontal asymptote to be y equals 6. So when I divide this thing, this multiplier, a divided by 7 has to equal 6. Multiplying by 7, I get a is 42. So the function that I can work with here, f of x, would be 42x squared over 7x squared plus 32x minus 15. Now we hope we still have the same vertical asymptotes, and certainly x plus 5 or 7x minus 3 are not going to divide out because the 42x squared doesn't factor that way. So let's go back and look at this graph and see if we have the correct vertical asymptotes as well as now the correct horizontal asymptote. So let's go ahead and take a look at that. So we will eliminate this function and change it to 42x squared. (42x squared over 7x squared plus 32x minus 15. And we'll see what we see. And then we believe we have a horizontal asymptote at y equals 6, but very difficult to see here. Let's go ahead and extend this. Aha. So now if I go ahead and I graph y equals 6, do you see how that can behave as a horizontal asymptote? So indeed, over time, this function is getting closer and closer to 6 in that direction, getting closer and closer to 6 in that direction. And the vertical asymptotes, when we look close in, right, the vertical asymptotes seem to be working as well as we look at the behavior of this function. Not moving very quickly, but indeed getting closer and closer to that vertical asymptote. Now, this is not the only possible answer. Remember, as long as this is 42x squared, I could have plus something x plus something as long as nothing else divides out. So really, the general form would be 42x squared plus something x plus something. Just make sure you choose b and c so things do not factor out nicely to cancel out those things in the denominator. So I'll just try a couple more of those and we'll see how they behave. So let's go back to Desmos one more time. And let's take 42x squared plus 2x plus 5. And we need to have a bigger window again to see how this is going. So you can see y equals 6 looks good. You can see the vertical asymptotes look good. If I change those numbers at all, minus 10x plus 12. Again, same horizontal asymptotes, same vertical asymptotes. So as long as we have 42x squared plus something x plus something divided by that, we should have a reasonably good answer. Only small chance that it'll fail is if you have one of the factors on the bottom divide out.